Good morning, metabolites. Today we are going to be talking about bisubstrate reactions. This is our second class, so today we are going to be talking about the kinetics of bisubstrate reaction. The first thing we are going to deal with is the rate equation for the rapid equilibrium random order mechanism. Now, I want you to be very attentive in this class because this requires a lot of attention to understand. Okay? So the first thing we are going to do in this particular derivation is to first of all classify the equations we are going to get in this equation. So pay close attention and to get the constants that are made available to us, and also to know the reference equations that will be needed later on in the equation. So in this equation we have 6 constants to consider, or 5 to be precise. So the first constant to consider is the dissociation constant from EA to EA complex, right? And that is KSA, okay? That is KSA. Second constant to consider is KSB, all right? So I want you to write all these constants down. KSB. Third is KMA. Fourth is KMB. Fifth is K itself. So these are the 4 main constants we are going to consider in this course as we proceed. I want you to pay close attention. If you understand all these things, you are going to understand everything we are going to be doing. All right? Now, we are going to derive 6 different equations and we are going to finalize it. All right? The first equation we are going to derive is called equation A. Second one is equation B. Third one is equation C1. Fourth one is equation C2. Fifth one is equation D. And the last one is equation E. These are the 6 different equations we are going to derive in this course. Take note on them. Then the reference equations we'll be needing in this particular calculation are these. So take them all down so that it will not be difficult for you. The first reference equation we are going to take is the velocity of this reaction, the speed of this reaction is V equals to what? Equals to K into E A B. That's the first reference equation. We'll need it later on. The second reference equation is this. The law of conservation of enzyme active site, which states that the total number of enzyme E0 is equals to the free enzyme plus the enzyme bound to A plus the enzyme bound to B, then the ternary complex plus E A B. Okay? And the third equation we are going to put to consideration is that at the maximum velocity of the reaction, V is equals to K times the total enzyme. Okay, that is to say, at V max, pay attention, it is equals to K times what? E0. So we are going to refer back to all this equation. That is why I'm taking my time to explain. So I want you to take note of these things we have brought out. Okay, take note of them. We'll need them later in this calculation. So now let's dive into the calculation fully. Okay, so in this calculation, the first thing, let me bring back the equation. You can see the equation here again. Now the first thing to consider is the law of mass action, because that's what we are using to solve everything here. Okay, so we are going to solve for the EA complex. How did we arrive there, and what is the constant for that? The law of mass action that was proposed by Goldbach and Wag, 2 great scientists, states that the rate of a chemical equation is directly proportional to its product all over its what? Its reactant, all raised to the power of the stoichiometric coefficient. All right, now after understanding this, the inverse of this particular law is the dissociation constant. We have the association constant and the dissociation constant. Okay, according to him, he said if A plus B come together in a reversible reaction like this, right? You have C plus D. The law of mass action is saying that, okay, this is the kinetic, the constant of the equilibrium, KEQ. It's saying that KEQ is equals to C, pay attention, D all over A B. If there's any small letter here, that is the stoichiometric coefficient, they will be up here, C, D, A, and B respectively. That's what the law means. But if the constant, if it is the reverse, that means the dissociation, that is from here, if it's from here to here, it will be the opposite, the inverse of this. That is, the law will now be 1 over KEQ. So for this particular calculation, we're going to consider the inverse because they are dissociation constants. Alright, so instead of writing product over reactor, we're going to write reactant over product because of the inverse, 1 over KEQ, inverse of this particular law of mass action, or inverse of this particular equation. Do you understand now? So that's what we'll be doing quickly. So we proceed to the next. Okay, proceed to the next. So the first thing we are going to do in this equation is the EA complex. And how do we get that? First of all, you know that E plus A, alright, is what gave you that EA that's in that first equation. Alright, EA. Now, since you've gotten this, and the dissociation constant here is K what? KSA. KSA. So here to be KSA equals to what? You understand that we are using the inverse, right? So to be KSA equals to E A all over what? All over EA complex. After getting this, what did you get? Okay, you cross multiply to solve it. When you cross multiply, this is what you have. You have KSA equals to you have KSA into EA complex, okay, and this equals to E, right, and A. Want to make EA the subject of formula, divide both sides by what? KSA. This cancels out this cancels. So this is your first equation. So you have gotten equation A, B. I told you we are getting how many equations? We are getting 6 different equations. So the first one has been resolved, and it's what? EA equals to E A, okay, all over KSA. This is equation A. Alright, hope we are clear with this. Thank you. So we get to the next one. The next one is equation B. The equation B is the EB complex. How did we arrive there? We're going to do the same. Now that you understand that law of mass action, we can easily do it, right? Thank you. So we proceed to how we get EB. Good. So for EB, it is E plus B, alright? E plus B is what? To give you EB complex, and the dissociation constant is KSB, okay? The same mechanism apply, okay? What will happen? You have KSB equals to what? Equals to E, the inverse, don't forget, B, all over what? All over EB. You're following, right? Good. Now, the same thing you did, cross multiply. When you cross multiply, this is what you have. You have KSB. Remember, the B is a superscript. KSB into what? into EB. Okay, EB all equals to E and B. Are following, Navi? Thank you. So after getting this, what do? Divide both sides by KSB. You want to make EB the subject of formula. You divide both sides by KSB. This cancels out this. So you have gotten equation B. EB equals to EB all over KSB. You follow it? That's very interesting. You see? So equation B is now what? This is now your equation B. You have EB equals to E B, alright, all over KSB. This is now equation 1. This is now your equation B. How many left? 4. Okay, this other 4 is very technical, so pay attention. So let's derive the next one, C1. And deriving C1 is not that complex, okay? Deriving C1 is not that complex. So for us to do that, we easily say that, okay, C1 is gotten from equation B, alright? And how do you do that? You solve for the EB complex. How did you get to EAB from EB? That's the first thing to do. Now, how do you do that? If you look at the equation, you will know that from EB to EAB, EB needs to bind with A to get there, and the constant there is Km what? Kma. So what you have is EB, okay, into what? Sorry, before you put this thing, you must put your A, okay? EB plus A will give you EAB. The constant here is what? Kma. Using the same mechanism, we say Kma equals to what? Equals to EB and what? A all over EAB, ternary complex. Alright, EAB. Are you following? EAB. Now you want to make this the subject of formula. You do the same, cross multiply. What will you have? You have KMA what? Into what? Into EAB. If you are following, you know that we have been repeating the same thing, but there's a little changes, so pay attention. Equals to what? Equals to EB and A, making EAB the subject of formula. You have KMA. This cancels out this. You have KMA. When you do this, what do you have? You have EAB equals to this, right? And that's not equation C. We still have to do something. That's why you need to be very attentive. After you've gotten this, the next thing to do is to substitute for EB from equation B. Now in equation B, EB is equals to EB all over KSB. So we are going to replace this particular EB here, this one you are seeing here, to replace it with that equation, and we'll resolve it. Now how do we do that? Okay, pay attention. So now we say EAB is now equals to E first, sorry, let me clean that. Alright, it's first E, alright, B. There was an A here, so you put your A, initial A, all over KS was KSB times what? Times your KMA. Alright? You have substituted for it. Are you with me? Good. Now, that is not all. We want to make E the subject of formula. Alright? How do we do that? To make E the subject of formula, these two here will come and multiply with this EAB, while the A and this B that is multiplying E here will come and what? Divide over here. Okay, divide over here. So that's what we'll do now. Simple. Say E is now equals to what? Is equals to K. First of all, is equals to E A B, alright? EAB times what? Times K S B and K M A all over what? All over A and what? B. So this is now equation C1. Are you following? This is equation C1. Alright? Then we proceed to the next. How do we get there? Simple. You are still going to do exactly the same thing that you've done, but this time around you are going to use EA. Right? So you are solving for the EA complex. Some people can already do it without me, so I want to give you a little privilege to be doing it by yourself. Let's see how you can finish the other one within a few seconds before we continue. Some people have already started. I love these guys. Okay, so go ahead and do it. Now the next thing for us to do is this shortly. CO. The next thing we are going to do is for the EA complex, the same thing. EA, all right, plus what? B is what will now give you what? EAB. You know, it's a random order mechanism. Okay, so when this happens, what's the dissociation constant? Is what? KMB. You're going to do exactly the same thing you did for the one we just finished. So what are you going to do there now? Simple. You say KMB, okay, which the dissociation constant is equals to what? Equals to EA times what? Times B, or B all over what? All over EAB, the product. You've gotten this. Now what next? What next? You know, cross multiply, right? This will happen. So you have KMB times what? Times EAB. Okay, follow suit. Times EAB equals to EA rather, forgive me, EA and what? And A. Okay, EA and B. Okay, how do you want to make EA the subject, EAB the subject of formula? KMB. This cancels out this. So what do you have? This. Now you substitute for EA from equation 1. How do you do that? Substitute for EA from equation 1. Simple. Just like we did initially. It will now be EAB equals to, pay attention, instead of EA you put, you understand, right? Yes. Instead of EA you put the equation. So how do you do that? You have EA times B all over what? All over, there's KMB here already, so the former is KSA from equation A times what? KMB. Now that's not all. You want to make E enzyme the subject of formula. How do you do that? Simple. Look, all here, this KS and KM will come over here and multiply, while this A and this B will come here and divide, right? So what you have now is this. So EAB will now be E equals to what? Equals to EAB, alright, times what? Times KSA KMB all over A and what? B. This is now your C2 equation. Isn't that easy? It's pretty easy, right? Good. Now let's go to equation E and equation D. These ones are quite simpler. Alright, they are quite simpler. So I want you to pay attention how we can arrive at equation E and equation D. Now equation E is actually gotten from this C2, all right? You are substituting for EA. You are substituting this into equation A, C2 into equation A, and C1 into equation B. How do we do that? Let's go together. I will show you. All right, it's a very interesting journey. Let's start from the very beginning. Okay, let's have another board, another page. Now, in C, equation D, you are substitute for E in A using C2. Now, let me show you that. The equation A is what? Initially, you say the equation A is E A equals to what? E and what? A all over K S A. This is equation A. You have E here, right? Look at E. Now, what you are going to do is, anywhere you see this E, you put the whole of C2 equation, because E is equals to something in C2. So you're going to do that now. How do you get that? Simple. You have E A, all right, equals to, first of all, EAB, because this is the equation that is in C2. EAB times what? EAB times KS what? KSA times KMB. There was an initial A, you put this one here, so times A, all right, all over what? All over KSA, that was in this question, times KM. Sorry, forgive me. Before you put KSA, first of all, put your A, B, and C. So in C2, we have A, right? We have B times this one that is already here. This one, that is KSA. Are you seeing? This is now equation D. Isn't it simple? Simple, right? Then we proceed to the next. The next is this. How can we get E? E is to substitute for E, that is equation E is to substitute for E, enzyme, free enzyme, in equation B using C1. Very easy, right? Some people can already do it without me, right? Just do it. Let me see how many people will be correct when we finally do it. Okay, I give you a few seconds. Can we go together now? Good. So let's see. Equation B is what? EB equals to what? Equals to E free enzyme plus forgive me, free enzyme, okay, plus B. All right. All over, let's do it again, please. All right, is equals to enzyme B all over KSB, isn't it? Now you are substituting for this E using C1. You know what you had is C1, right? Good. So we are going to do that. How do we get that? Now, simple. I thank God for those that are following their understanding. Doing exactly the same thing we have done before. Okay. Now you have EB equals to, instead of E, you have EAB. You write the equation in C1, EAB, right? Times KSB times KMA. There was a B here, so you put your B, right? All over A B times what? This KSB that is here, KSB. This is now equation E. So you have an understanding starting from the very beginning. So now that we have gotten all our 6 equations, equation A, equation B, and equation C1, C2, D, and E, it is time for us to now go back to our reference equation. The first reference equation we are looking at is a equation for the law of conservation of enzyme active site that state that E naught, okay, E naught is equals to what? The free enzyme, right, plus EA plus EB plus EAB, right? This is the first equation we reference back to. Now, this means that the total number of enzyme E naught is equals to the free enzyme, then the enzyme in the binary complex and the enzyme in the ternary complex. That's what it simply means. Now we're going to substitute for each of these, okay, using the equations that we have, right? Equation C1 and C2 we're going to use to represent E. Equation D for this. If you look at equation D, you see that this is equals to something. Equation E, this is equals to something, right? And equation C1 and C2 is for this. So let's do that quickly. First of all, we have E naught equals to what? E is equals to what? E is equals to EAB, right, times KSA, okay, KSA times KMB all over A B, right? I used this equation to represent what? To represent E, plus EA is equals to what in equation D? Is equals to EAB, right, times what? Times KSA times KMB, then what? A all over A. Thank God for those that are following, B and KSA. That's all. That's for equation D. Yes. All right. Now plus, what do we have in equation E? We have EB equals to what? Equals to EAB. All right. KSB, okay, KSB times KMA, then B all over A times what? B, are following, glory to God, all over KSB. This is what we have in equation what? Equation E plus the ternary complex. Alright, now that you have this, what's the next thing to do? Look through. You have completely represented every of these complexes with their equations, right? Now it's for you to resolve this. If you look at it very well, you will find out that there are some repetitions up and down, so we're going to cancel out. How do we do that? So you have A here, okay, you have A here too, forgive me, you have KSA down, you have KSA up too, so you have cancelled out. All right, then come to the next one. You have B here, you have B here too, you have KSB here, KSB here, cancelled out. Right, so now let's write our new equation, okay, in this form. So the first one, this one remains the same, right? So we have E naught equals to EAB, right? Take note, KSA times KMB all over A B, plus this time around you have just EAB right? Times what? Times KMB all over B. The rest has been cancelled out, plus this time around you just have E, sorry for that obstruction, you just have EAB, alright, times what? KMA only, all over what? All over A, right? That's the only thing you have. All the rest has been cancelled out, plus EAB. Alright? Now the next thing to consider is the fact that there is a common factor. And that common factor you can see in all the equations is EA here, EA here, EA, EA. So we can factorize that, right? All the mathematics students, you can agree with me, right? So we have E naught equals to, if you factorize EA out, this is what you have. If you did factorization in mathematics, right? Now EA has been factorized out, so what you have is the other component. And how do you write that? You simply say, okay, this is equals to KSA, alright, times KMB all over A, okay, B, plus just KMB over B, because I factorized out the other one. So what you now have is this, alright, plus what? Plus KMA all over A, then plus 1, because if you factorize EAB, you have only 1 here, right? That being known, we proceed. Looking at the equation very well, we want to make EA the subject of formula. That means the whole of this will come over here and what? Divide. Okay, because the relationship between EAB and the whole of this is multiplication. When they cross over the equals to sign, they will divide, right? So that's what we'll have. Okay, so look at it. What you now have is EAB, okay, equals to E naught all over KSA times KMB all over A times B plus KMB over B, okay, plus KMA over A plus 1. So this is what you have. Hope you are following. This is what you have. Now, how do we proceed from here? How do we proceed from here? So the next thing for us to do is this. Okay, now that you have gotten this, we go back to the second reference equation I wrote down before we got here. The second reference equation is what? We said that we have V equals to EAB times what? Times K. To resolve this, we want to make EAB the subject of formula in this reference equation. Alright? How do we do that? We easily say that, okay, to make EAB the subject of formula, the relationship between EAB and K here is multiplication, so it will come here and divide. So what you now have is this, okay? You now have V over K equals to EAB. So you can easily say that anywhere you see EAB, you can replace it with V over K, right? So that's what we'll now do. So what you now have is, instead of EAB equals to E naught over this, you now have V over K, because EAB is equals to V over K, alright? So let's look at what will happen now. So what you now have is V over K equals to E naught all over KSA times KMB all over A, right? B plus KMB over B plus KMA over A plus 1. Alright? This is what you now have, because I have replaced EAB with what? V over K. Are you following? Now the next thing is simple. If you have V over K and you want to make just V the subject of formula, K here is dividing, so it will come over and multiply. And when it multiplies, you know, of course, it will multiply with the numerator, not the denominator, right? Because it is the inverse of, that means it will be K over 1 that will multiply at this side. So you have K E naught. Simple, right? Good. So what we now have is this, okay? Without wasting time, you have V equals to K E naught, because K came over here and multiplied, right? Okay, thank God you understand. So K E naught over the whole of this as KSA times KMB. Sorry for that. KSA times KMB. Okay. KMB all over A and B. Right? Plus what? Plus KMB all over B plus KMA all over A. Okay? For those that are following, God bless you. I know you will understand quickly. So this is what you now have. Then the last thing for us to do is this. Now that you have seen that, okay, we have arrived at almost the end, what's the last thing to do? The last question I gave you, the last reference equation I gave you was what? I said V max is equals to KE naught. Is that not the last one? Where I said at V max, it is equals to what? KE naught. So the last equation is to what? Replace this KE naught with V max, because V max is equals to KE naught. So you see that we are done with the 3 reference equations. Alright? So what you now have is this, okay? As the final equation for your rates equation is that you have V equals to V max. Are you following? All over K SA K MB all over what? All over A times B plus KMB over B plus KMA over A plus 1. This now becomes your final answer. Alright? I finally derive the speed of this particular random order mechanism. This becomes a velocity. Alright? So it is not actually difficult if you have followed from the beginning. Alright? So in our next class, we are going to look at the mathematical expression that explains the binding of oxygen to hemoglobin. So I want you to watch this video repeatedly until you get the knowledge behind it. Thank you.